Chapter 1 from ICSE 10th standard. Book being used is Selena publication for you all, so you can use that. Okay, just look here. When I talk about force, let me start with the definition of force. Yes? So what exactly the force is defined as? Okay, so I'll write the definition over here. Look here. Force is defined as any physical quantity that leads to change in shape or state of the object. State of the object. हमने यहाँ पे दो बातें लिखी हैं. Definition is very special. Mind it. This definition is very special. Such of definitions in which force is defined by something cannot be used to measure the force. Yes or no? Any physical quantity that you know, understand is what I'm trying to say. Any physical quantity that you know can only be used. Just one sec. Okay, yeah, I'll repeat. So any physical quantity that you know is basically used to perform certain sort of activity or some activity in nature or some artificial activity corresponds to some or other physical quantity. What does this mean? There are two definitions of every physical quantity. There are two definitions of every physical quantity. One physical quantity has got, the first definition, that definition can be written, can be called to be qualitative definition. Qualitative. What does this mean? Every physical quantity that, when defined, gives the idea of physical quantity, but does not help in measurement, is called as qualitative definition. I'll repeat. Just one sec. Yes. Any definition of the given physical quantity which only gives you the idea of the physical quantity but does not help in the measurement is called as qualitative definition of that quantity. So the definition that we have just written here on board, this definition which we have written here on board is basically the qualitative definition. Okay, this does not give you how to measure the force, right? It only talks about what exactly the force is. Yes, we'll see. As per the definition, what is force? Force is defined as any physical quantity that leads to change. This is very important. Change in what? Change into either of the two things, either the shape or the state of the object. Got it? Yes. So if suppose I have got an object like this, and I apply the force, three things can happen. First, second, and third. First is change in shape will happen. Change in shape. Second is change in state can happen. State. Physical state? No. Mechanical state. Okay, physical state comes over here itself. Okay, so when I say change in state, I am talking about mechanical state. Okay, what are the mechanical states? That video I have already made and I have shared to you. But still I'll tell you there are four mechanical states. Rest, uniform motion, uniformly accelerated motion, and non-uniformly accelerated motions. Okay, so these are four states which is already discussed in the previous video. Link is available. I'll give you in the description also while uploading this on YouTube. So here, change in shape, change in state. And the third thing which can happen is change in shape as well as state. As well as state. So if I apply a force on the object, there can be change in shape, there can be change in state, or there can be change in shape as well as state. The objects or the bodies which undergo these two things are elastic or non-rigid bodies. Are elastic or non-rigid. This is better word right now. It is called as non-rigid body. Okay, and this is something which happens in just rigid bodies. Okay, just rigid bodies, because shape of the rigid body does not change on application of force. Got it or not? Yes?
Yes, sir.
So understand this. Whenever the force is applied, you get such kind of effect depending upon the type of body. If the body is non-rigid, the effect can be either of these two. If the body is rigid, the result of application of force will be this only. Okay, how many states are there? 4 states. If a body is moving and you apply the force, it will stop or it will start moving faster. This is what can happen, right? If the body is already at rest, you apply the force, it will start moving, either with constant speed or with variable speed, right? So those things can happen. So this is something which you need to remember. This will make you understand the exact definition of force. Clear? Yes, please note this down. Note this down in your notebook. Mind it, this is the qualitative definition of physics. It is not the quantitative definition. There is difference between both of them. Note this down. So remember this. Every physical quantity has got two types of definition. One is qualitative definition and other is quantitative definition. This gives you what exactly is the physical quantity all about, and this gives you how can that be calculated, right? So this is also called as formula, right? Yes, no? So quantitative definition of force was given by Newton in his second law. You guys remember second law? Rate of change of momentum with respect to time is directly proportional to the force applied on the given body. You guys remember? Right? So F is equal to ma. F is equals to ma, rate of change of momentum with respect to time. This is the definition. Okay? So I'll write here quantitative definition now. Force is defined as the rate of change of momentum with respect to time. Yes, so force is defined as the rate of change of momentum with respect to time. And mind this well, this change of momentum is also called as impulse if it is very small. Getting it or not? So if you divide the impulse by time, you get force. F is equals to ma. This is the formula, right? So I'm writing the formula now. F is equals to ma or mv minus mu upon t, whatever you call it as. It is same thing. Okay, right? So this is basically momentum, change in momentum. This is final momentum mv, initial momentum mu upon time taken. So this is change in momentum upon time taken. Change in momentum is nothing but impulse if it is very small. If you multiply the force with time, you get impulse. So this is the formula for impulse. What is formula for impulse? There are two formula. Firstly, change in momentum is called as impulse. So that will give you one formula. Other formula is multiply force with time. You'll get impulse. So F into T is the formula of impulse. So these are multiple ways. Okay, this is momentum mv or mu. This is mv because final momentum. This is initial momentum. Please note this down. Just note this down. Done?
Yes, sir.
Flare up.
Sir, just a minute.
Yes. Now I'm ready. In this chapter, we are going to study only about rigid bodies. Understand this. When I'm saying I'm going to study only about rigid bodies, what does that mean? I'm not going to study those bodies which are not rigid. Which are not rigid. So for that matter, if I say, sir, this is rigid body, I'll make a shape, say this is rigid body, okay? I've made a shape. If this is a rigid body, right? So if I apply force on this, see I'm applying the force. If suppose I apply force, so on the application of force, what will happen? What will happen? There will be something called as change in state. So it will be either motion or rest, right? Then in motion you can have uniform, non-uniform, non-uniformly uniformly accelerated, non-uniformly accelerated. So it will be either motion or rest, out of which out of which in the entire chapter we will be having one assumption. Assumption is, what is the assumption? Assumption is that rigid body is already at rest. So rigid body is already at rest. This is our assumption. This body I'm talking about. Okay, so this is our assumption that it is already at rest. So if it is already at rest and you apply the force, if it is already at rest and you apply the force, then rest will not be converted to rest. Okay, so rest will be converted to motion. Rest will be converted to motion. So the entire motion that we are going to experience can be categorized into two major groups. Okay, right? So I'm just writing the category of two motions. One is what? Tell me. One is transitional motion and translational, you can say, not transitional, so sorry. Translational motion, and other is rotational motion. So these are two types of motions. When I say translational motion, what does this mean? This means linear motion. Linear motion. Okay. When I say rotational, it means angular motion. Getting my point? Linear motion, angular motion. Clear? So this is translational and this is rotational. Okay. Yes ki no?
Yes, sir.
Okay. Just note this up.
So,
Yes.
so my father needs this device, so I am switching the device. So is it okay if my voice and video is not audible?
Yeah, it is okay. No problem. No problem. You can just leave the chat over there. No issues.
Yeah. So I am switching my device actually, and it is a bit older version, so it does not support mic and that.
No problem. No problem. No problem. So now, if I say this is the line, this is the central part. I'm drawing this vertical line. Okay. Now listen here. What undergoes motion, by the way? What undergoes motion? What is it that undergoes motion?
Rigid body.
Perfect. Very good answer. Sir, it is rigid body. Rigid body undergoes motion. So rigid body is made up of many particles. Yes or no? A rigid body is made up of many particles. Say suppose if this is the body, where should I make it? Okay, I'll make it here itself. If suppose this is the body, it is made up of many particles like this. Yes or no? Correct? So what really happens is, this rigid body, I am considering just two particles. Understand this. Okay? Yes. If I move this rigid body as per translational stuff from this position to this position, what will happen? What will happen? This entire body is shifted at this point. When that is shifted, understand this. Yes or no? Yes, no.
Yes.
Now my question, if suppose this is 2 meters, then tell me What is the distance between this particle and this particle? What is the distance between this particle and this particle? What is the distance?
2 meter.
2 meters.
Perfect. And what is the distance here? I mean, sorry. Got wrong.
2 meters.
2.
Even this distance is 2 meters. Hello? Right? Yes, Kino? Sir, even this is 2 meter and even this is 2 meter. Right? So this is the quality of translational motion. That whenever there is translational motion which an object is going across, it means that all the points on the object will move at the same distance. Will move at the same distance. If suppose this is 2 meter, this will be 2 meter, this will be 2 meter, this point and this point will be 2 meter. Anywhere you go, it will be 2 meter. So all the points of a body will travel the same distance at the given time. This is called as translational motion. So I'm writing here, just look at the definition. All the points, या फिर मैं point particles बोलता हूँ, या कई लोग उसको point masses भी बोलते हैं, ठीक है ना? हाँ, of the given body undergoing translational motion. ये जो मैंने x डैश लिखा है ना, इसको ट्रांस पढ़ते हैं, ट्रांस, ठीक है ना? तो ट्रांसलेशनल मोशन travel equal distances at any given point. At any given point. I hope it is understood. ये बहुत इंपॉर्टेंट है, ये वाला पार्ट, ये वाला equal distances at any given, not point, so sorry, at any given time. Clear?
Yes.
This is the definition of translational motion, and the beauty of it is this. Now let us talk about rotational motion. ठीक है? है ना? Sir, rotational motion is circular? No. There is difference between circular motion and rotational motion. See, understand this. What is the difference, sir? Mayank, is it okay?
Yes, sir.
Okay. What is the difference between circular motion and rotational motion? Mayank? Difference between circular motion and rotational motion.
Rotational motion means rotating around itself, and circular motion means revolving around the.
What is the similarity?
So you are asking me?
Yes. What is the difference and what is similarity? Rotational and circular.
So I can't tell.
Okay. Anuj, I expect the answer from you.
Sir, in rotational motion, the body rotates around a fixed point.
Okay. That happens even in circular motion. There is the fixed center.
So in a circular motion, maybe a body rotates on its axis.
Huh?
Again, circular motion means to revolve around the, like sun and earth.
Yeah.
Earth is rotating around itself and complete.
Revolving outside. Now understand this. I'll just repeat the answer. One answer has been given by one of the students. Sir, rotational motion means when a body is there. I'm just going to, change the video so that it will be easy for you to comprehend. Now understand this. Rotational motion means when a body is there. Say this is the body. This body will have many particles. Yes or no? This body will have many particles, right? If all the particles, my mind, my word, if all the particles are performing, are moving through a circular path, all the particles are moving through a circular path about an axis which lies outside the body. ये देखो. Can you see this? Yes? Marker? This is the marker, right? Say suppose this is the axis, and this is the object. If all the particles of this object, they are moving on a circular path around the axis which lies outside the body. ये हाथ के बाहर है ना? This axis is outside the body and this is body. Yes, so all the particles of this body, they are moving a circular path around an axis which lies outside the body. Yes, no? Correct? So such movement is basically circular motion. And when Suresh, if this is the object, okay, and say it has got again two particles, and this entire object is moving on the circular path.
So we can't see the white.
We can't see it.
Oh, okay, so sorry. I just messed it up. Okay. So this is the object, and the object is moving on a circular path like this. Okay, so it is a circular path. Now in this circular path, if the object is moving like this, where is center? Where is center? Center is here. Center is here. If center is here, this is circle and center is here. So what really happens? The axis of rotation lies outside the body. Okay. So if the axis of rotation lies outside the body, this is the body and axis of rotation is here. And this body is moving like this. So what really happens is all the particles of the body, understand this, what am I trying to say? All the particles of the body are in circular motion, are moving on the same path. Right? Mind it, they are all moving in the same path, but they are not going to cover the equal distance. Sir, they are going to cover the equal angle, but they will not be covering the equal distance. Okay, right? So understand this. So why do I mean to say this? What do I mean to say this? The object which is far outside will cover more distance, and the object which is quite inside, near to the center of the circle, will cover less distance. Yes or no?
Yes.
Right? So they are not going to cover the equal distance, but yes, they are going to trace the equal angle, and they all will be in the state of circular motion. All the particles. But when we talk about rotational motion, see the difference. When I talk about rotational motion, this is the object, and axis of rotation is somewhere in the body. So it can be here, it can be here, it can be here, anywhere. So if suppose it is here, then this will be the axis, and the object will move like this. Can you see this? If suppose that this is the center, then again the axis will be like this, and this object will be moving like this. Yes, no? say, consider this mobile phone. Can you see this mobile phone? Okay.
Yes.
If the axis is here, the object will move like this. If the axis is here, the object will move like this. Get it?
Yes, sir.
Yes. If axis is here, the object will move like this. So everywhere the object is moving, but the axis is in the body. तो सर डिफरेंस क्या आता है? What is the difference which is really making it so engaging? The difference is here all the particles of the object are on the circular path, but here at this particle, at least one particle will not be on the circular path. Which particle? The particle through which the axis is passing, that will not be on the circular path. Getting it?
No, sir. This point I didn't get.
Okay. See, understand this. If I talk about this particle, okay, so it will go on circular path like this. Yes, no?
Yes.
If I talk about this particle, it will again go on circular path like this. Yes, no?
Yes.
But if I talk about this particle, this will not go into circular path. This will keep rotating at its own point.
Yes.
Like this.
Yes.
All other particles will move around this point, but this particle is not going to move around any other point. Got my point?
Yes.
Right?
Yes, sir.
So this is the basic difference between circular motion and rotational motion. Right? So if I have to define this up, how will I define it up? Look here. I'll just draw a figure. So I've drawn a figure here. I will take one axis of rotation as per my wish. So I'm taking this point and here I'll draw the axis of rotation. So see, this is my axis of rotation. Okay? Right? And I can move the object in this direction also and in this direction also. Yes or no? Yes or no? I didn't get the
Yes, sir.
response. Okay. So if this is the case and I put the force like this, it will start moving like in this direction. If I put the force here, if I put force here, okay sir. But if I put force here, here in this direction, here in this direction. So this process will continue, right? So this particular side will be called as clockwise. And this will be called as
Anti-clockwise.
Anti-clockwise, right? So rotations can be in two directions, either clockwise or anti-clockwise, depending upon the force or the force applied. Depending upon the force applied. Now understand this. If I have to define this rotational motion, it is when all particles of body except the center of axis move in circular trajectory. Around the है ना, मैं यहाँ पे मैं नोट लिख रहा हूँ, center of axis is called as pivot. What? It is called as pivot. By pivot, I mean that is the point around which everything is going to move. So this is the point where axis is going to be. Yes. So center of axis is called as pivot. Okay, just note this down quickly. Note this down. For video people, you can pause the video and then note. Just pause it up and note.
Done, sir.
Do not forget to number this up. It's very important. So here we go with the third very important point. What leads to translational motion and what leads to rotational motion? We all know that motion is caused because of force. Yes, no?
Yes.
From rest, an object undergoes motion. Why? Because the force is applied. Right? So the translational motion is also caused by force and rotational motion also is caused by force. So if both the motions are caused by force, then why are they different? If force is causing this and force is also causing this, then what is the reason? Why are they different? The difference comes because of the mode of application of force. Right? So this line and the next line is going to really explain you very, very important per text. Let's see. So here we go. This motion is caused by force. And how about this motion? This motion is caused by moment of force. This is the basic difference. This is caused by force and this is caused by moment of force. So such a big name, no problem. I'll write you a smaller name. Can you say this? It's torque. Torque. Force is represented by F, small or capital. Torque is represented by this symbol. Look at the symbol. It's very interesting. Okay. Then from here, angled T, curved T. This is T only, but curved one. Okay. So this is called as torque. So it's torque. Okay. The force is F, torque is torque, which is also called as moment of force. Some people call this as angular force also. What? Angular force also, because rotational motion actually is angular motion. Okay, right? So angular force. Now look at this. I'm just going to draw certain diagram and explain few things. If this is the object, and I apply the force like this, say this is the ground, this is the ground, or the flat surface, whatever you call it as. If I apply the force like this, yes, the object moves from first point to second point. So this is point A, this is point B, or position A to position B. Yes, the object moves on application of force from this position to that position. Right? Yes, now understand about this. In this case, what happens is, an object is placed like this. Or I will not make diagram here, that will confuse you. I'll make it here. An object is placed like this. Okay. Yes. Now force is not applied like this. Force is not applied like this. So then a point is fixed either on this side or on this side, wherever. Some point is fixed. It is selected and fixed. Say this point is fixed. Fixed point. Then I will apply the force. I'll apply the force in the direction perpendicular to the length, either on this side or on that side. Clear? Now understand this. I will decide where should I apply the force. So suppose if I decide कि मुझे force यहाँ पर apply करना है, यहाँ पर apply करना है, यहाँ पर apply करना है, कहीं भी apply करना है, wherever I want. Okay, so I'll decide that point where I will need to apply the force, and after deciding that point, here I've decided this point. Okay, after deciding this point, you will apply the force, but not into the direction along the length, but rather onto the direction perpendicular to length. Got my point? Understand this. When you apply this force here, the result is this entire thing moves, and it gets to become like this. You know? This I've made dotted. Yes or no?
Yes.
Right? So the movement has been from this direction to that direction. Anti-clockwise. Right? So this thing, the one which is applied, say this is force. This is force. Even this was force. But the difference is now from here to here, there is one more quantity which is called as B. Which is called as B. It is distance of the force from the fixed point. Yeah, distance of the point of application from the fixed point. या फिर perpendicular distance of the force from the fixed point. Repeat. What is D? B is the
Perpendicular force from the
Force.
Point.
is the perpendicular distance of the force from the fixed point. From the fixed point. Okay? Yes. Now this thing is very special. Why? Because this gives you the concept of torque or moment of force. Okay? It is given by the formula. I'm writing the formula. This is given by the formula. Tau is equal to F into B. Magnitude wise. What am I saying? Getting my point or not?
yes, sir.
Yes. So if you put it like this, it is vector quantity. Actually, you know scalar product, vector product and all.
Yes.
Okay. We all know that F is equals to ma. F is equals to
MA.
ma. F is equals to ma. So when I say tau, the magnitude of tau is obtained by the formula F into D. F into B. F into B. So this is very special. Why? Because tau is basically a vector quantity. Torque is a vector quantity, clockwise or anti-clockwise. That is what you are going to define, right? Yes. So it is called as F bar cross D bar. So tau bar is equals to F bar cross D bar. Tau bar is equals to F bar cross D bar. This is the general formula which people follow. Yes?
Sir, why that bar is there?
Okay. Tau is F bar cross D bar. This is what generally people feel, but this is not the case. Why? Because I'll tell you. If you guys remember how to multiply two vectors, you will know that direction of the vector is given by right hand thumb rule. Yes or no? Right hand thumb rule. Yes, no?
So we don't know that.
Okay. So actually this formula, I just tell you this much, you just remember, this formula becomes wrong formula. because of direction. Because of direction, the actual formula is tau bar is equals to b bar cross f bar. Tau bar is equals to b bar cross f bar. You just remember this formula, it is very important. Tau bar is equals to d bar cross f bar. This is the correct formula and this is the wrong formula. You know why? The reason is clear, because of direction thing. Okay, magnitude wise tau is equals to f into d. Magnitude wise tau is equals to f into d. In general tau bar is equals to d bar cross f bar. Mind it. सर मैग्नीट्यूड वाइज ऐसा क्यों होता है? क्योंकि ये क्रॉस प्रोडक्ट का एक फॉर्मूला है जो आप लोगों ने शायद अभी सीखा नहीं है, हम बाद में कभी सीखेंगे तो आई विल एक्सप्लेन यू. बट जस्ट रिमेंबर दिस दैट मैग्नीट्यूड वाइज इट इज रिटन एज tau is equals to fd and vector wise, direction wise, it is written as tau bar is equal to b bar cross f bar. B bar cross f bar, where understand this, what is d bar? D bar is called as moment arm. क्या बोलते हैं इसको? Moment arm. D bar is called as
Moment arm.
exactly. Anuj, okay?
Moment arm.
Yes. And what about F bar? F bar is called as force. F bar is called as force. And what about tau bar? Tau bar is called as moment of force. Clear?
Yes.
Yes, no? So this is very, very important thing that you must remember. Okay. So D bar is momentum, F bar is force, tau bar is moment of force. I did not have space, else I would have written this downwards. Okay. So you people are going to write this now. Just write it quickly. And write both the things up. What is wrong, what is right, you must understand. F bar cross D bar is wrong. D bar cross F bar is correct. You need to write both of them. Tau is equals to FD. Magnitude wise it is this. Vector. Important point which is called as moment of force. Right? So now our target would be, our major target would be to understand the concept of moment of force. So moment of force is actually obtained by something called as torque. है ना? Torque is represented by tau bar. And it is obtained as d bar cross f bar if this is the body and this is the pivot point. Pivot point matlab fixed point. Yes, and if suppose I am applying force here, say I am applying here F1, right? So this distance will be called as D1. Yes, ki no? Paka? So I'll call this distance as D1. If suppose I'm applying force here, I'll say this is F2. So automatically this distance will be called as D2. And this is D1. Yes, no? So in this way, if suppose I'm applying force here, F3, then this distance will be called as D3. Yes or no? Yes. And accordingly, understand this. If I want to find out torque over here, so this will tell me to find out tau1, this will tell me to find out tau2, and this will tell me to find out tau3. Tau1 is obtained by B1 into F1 magnitude wise. Tau 2 is obtained by V2 into F2. Tau 3 is obtained by V3 into F3. Barabar? Clockwise moment is always negative. Anti-clockwise moment is always positive. This is the way of writing it, okay? Instead of writing anti-clockwise something, I will write plus. Khatam. So plus means anti-clockwise. Minus means clockwise. Clear? Every object that we can see can be said to have the experiential torque. I'll give you a very good example. You know, door. Have you seen door?
So clockwise should be positive and anti-clockwise should be negative.
No. Clockwise has to be negative, anti-clockwise has to be positive.
Okay.
Now understand this. This is the notation which we have been using as a standard form. Nothing more. Angles are represented in this way. Have you seen door?
Yes.
Yes.
Okay. So we will take an example of door now. ठीक है ना? Here we go. Say this is the door. Okay. So this is the door, and this is that hinge wala area where door is connected. Yes.
Yes.
So this becomes the fixed point. Yeah, fixed line. Yeah, fixed part. Yes or no?
Yes.
Yes.
Sir.
So this is the fixed one. Now see, it's very simple, right? This is fixed. If I apply the force here, it will open and close. Correct? The force is
Yes.
to be applied perpendicular to the door. If door is like this, force will be applied like this. Yes or no? So if this is plane of the door, this is the direction of force. Okay? So this will be the direction of force, like this. So it is perpendicular. Yes or no? Yes, no?
Yes, sir.
Can you see this? Right? So this will be the direction of perpendicularity. If perpendicularly we apply the force, door will be open like this or closed like this. Clockwise, anti-clockwise movement will happen. Now understand this. While opening the door, handles are placed here. If this is the hinge, handle is always placed here, you know? Yes, you know?
Yes, sir.
Suppose if I try to open the door from this point, what will happen? Door will get opened, but force required will increase. Force required will increase. Yes or no?
Yes, sir.
Right?
Yes.
Yes. As and when you keep on moving to the point closer to the hinge, the force applied would be increased.
Yes, sir.
Yes, sir.
If this is the hinge, right? This is the door. I'm going to apply the force perpendicular to the plane of the door always. Now, if and when I keep on moving towards point, my force application will increase. Yes or no? The amount of applied force will automatically increase, right?
Yes. Yes.
Yes. Keep moving, moving, and at a time will come when you arrive at this position, at this point, at the point where hinge is connected. Now, after
It
reaching
will
here,
not move.
to apply the force. Not just you, even elephant, if it comes and applies the force, the door will not be opened. It will break down but not open. Why? It will break down but not open. If I apply
Because
the
force applied is directly proportional to the
Zero.
perpendicular distance.
very good. I think somebody is coming up to the right answer. If this is the point, this is the fixed point, I'm applying the force here. Yes. If I keep moving towards this particular direction, to this
The
point,
whiteboard not
Huh?
visible.
so whiteboard is not visible. Okay, right, this is the fixed point and this is the force. If I keep moving from this point to the internal ones, near and near to this fixed point, pivot point, the time when I reach here, however strong force I apply, whatever can be the magnitude of force, it doesn't matter. This particular bar or window or any particular door will not open. Why? Why is it so? Because distance becomes zero. So what? For opening a particular door, rotational effect is important. For opening a particular door, rotational effect is important. This is called as moment effect, right? Rotational effect is obtained by torque. More is the torque, more would be the rotational effect. Less is the torque, less would be the rotational effect. Understand this. More would be the torque, more would be the rotational effect. So, because torque depends upon D and F, if I come closer to A, my value of D will decrease, right? But I have to open the door, so same torque will be needed. Yes, so if I decrease this, but the same torque is needed, automatically force will increase. Yes, no? Right? If I decrease D, automatically force will need to increase. Yes? Yes? If suppose I have to decrease the force, then what will I need to do? The point of application ka distance from pivot point needs to be increased. Barabar? Yes, so force will need to be applied from the various different points which are at the larger distance. Yes, now see here. If I reach to the point of pivot, distance becomes zero. When distance becomes zero, 0 multiplied by infinity is 0. The torque effect will become 0. When torque effect is 0, moment of force is 0. When moment of force is 0, it's done. You cannot open the door.
So your video is freezed. It is not visible.
Okay, no problem. But is it audible?
Yeah, sir, it is audible.
Then it is okay. So now I'll just repeat once again. Tau is equals to do into F. Torque is directly proportional to moment arm D. Right? Second, torque is directly proportional to force applied F. Third, moment arm and force applied are inversely proportional. Okay, this formula tau is equals to F into D, which is actually D into F. Hello? But magnitude wise you can write anywhere. Vector wise it is tau bar is equals to D bar cross F bar. Okay, it has got three quantities, tau, D and F. If I give you any two, third can be obtained. Yes or no?
Yes.
Right? Yes? So I'm connecting the camera now. Hello, till the time I connect the camera, you guys can start writing. You remember the diagram?
Yes.
You all remember? Can you make it? Can you all make it? Just do it.
Yes.
So wait, I will share the screen. I have taken a screenshot.
Oh, cool. Do share it up.
So is it visible?
Yes, it is visible now.
Yeah.
Great. You just start doing this. For those who are waiting recording lectures, pause the camera and pause the video and then continue writing. Question is, this is a very important question which I am going to ask. Okay, actually I have asked. The factors on which torque depends. The factors on which torque depends.
Magnitude of force.
Second.
Perpendicular distance from the pivoted point.
Now here one very important thing which you need to understand. It's not the magnitude of force, it is complete force. Okay. So magnitude, if I say, it means I am talking about just the magnitude of torque. I am asking the complete torque. Okay. So torque depends upon complete torque depends upon force and momentum. Okay. So if I say magnitude of force, then third point will be direction of force also. Yes, then it will become three dependencies. First will be the factors on which torque depends. So the first factor will be magnitude of force. Second, direction of force. Third, length of moment arm. Magnitude of force, direction of force, length of moment arm. Factors affecting the torque. Just write this down. Here we go. Right? So now, this is what I'm just rubbing this off.
कौन से टेबल में जा रहा है?
मैं अलग तरीके से बता रहा हूँ, नहीं एकदम छोटे में
क्या
विजुअली है ये बराबर है मतलब नहीं क्या.
So first is magnitude of force. Magnitude of force. Second,
Direction of force.
बहुत अच्छे. So it is direction of force. Third,
Movement arm.
length of moment arm. यानी कि moment arm length. अच्छा यहीं से एक और कंसेप्ट निकलेगा, मैं बता देता हूं तुम लोगों को. चलो ये भी, सपोज दिस इज अ रिजिड बॉडी. Okay, this is any particular rigid body. This rigid body will contain many points, yes or no?
Yes.
These all are point masses or point mass particles, yes or no?
Yes, sir.
बराबर ना? पक्का? Do you guys know, whenever there is a body, whenever there is body, it will be affected by something called as gravitational force, yes no?
Yes.
And the gravitational force on earth, understand this, यानी कि अर्थ के ऊपर earth's gravitational force, इसको हम एक और नाम से जानते हैं, बताओ क्या? इसको एक और नाम से हम लोग जानते हैं. There is one more name which we know it.
kgf.
Force on the given particle. हाँ?
Kilogram force.
Weight.
क्या?
हाँ, weight.
It is, sir, it is weight. Weight का मतलब होता है Earth's gravitational force on the body. Yes, it is denoted either by Newton or by kilogram force, whatever you call it as. Yes, Pakka? Yes. So this is basically the weight of an object or the Earth's gravitational force. Now understand this. If this is the body which is already there into the Earth's gravitational field, what will be the scene? The scene will be that Earth is going to pull this particular body down. Yes, no? So instead of considering all these particles, I am considering just 4 particles, okay? So that it becomes easy for you to understand, nothing more. Suppose if this is the particle I am interested into, this is first particle. So W1 would be the force. This is W2. Yes, no?
Yes, sir.
This part is W3, and if suppose I take this force, this particle, so gravitational force will come out to be
W4.
W4. Yes or no? Yes or no?
Yes.
Now
Yes.
each of these particles, just consider this. If I say first particle is this, then don't you think this particle is surrounded by many particles around itself?
Yes.
If I say this is the fixed particle, what am I trying to say? This is the fixed particle. So automatically rest other particles which are experiencing the force will not just experience the normal force, they will experience the moment of force. Yes or no?
Yes.
How? This particle is at some distance. Yes or no?
Yes.
it will experience the force into distance, because force is already downwards. So if this is the particle, force is downwards, now force is downwards like this. So if force is downwards, the distance is perpendicular to force, so automatically it is experiencing the torque. Yes, so this is there the distance, because of which this weight will be resulting into the torque. Similarly, from this point, even this point is at some distance. Yes, no?
Yes.
Even this will make you experience some torque. Let us talk about this.
Yes.
Right? So every single point, now understand this, all the points which are on the right hand side of this part, they will force the object to go in this way. This way means what? Rightwards, which is clockwise. Yes or no?
Yes, sir.
Right? So the entire plane will be forced to move clockwise. Correct? So if I hold any object, say if I pick this up and hold this object over here, for example, say this is the surface. If I hold this object here, what will happen? It will tend to go down, see? Yes, no?
Yes.
It's
Yes,
just
sir.
down by default. I have to hold it more. Generally, it is going down. Yes or no?
Yes.
If I hold it like this, it will fall down. If I hold it by one finger, like this, it will fall down. Yes? Acha. It will fall in which direction? Clockwise direction. Yes,
Okay.
no? If I take this finger and go to this point, okay, now see, this is the object, this is my finger, I'm going on this side, what will happen? This will fall on this side, anti-clockwise. Yes or no? Why is
Yes,
it
sir.
Yes.
so? Why is it so? Because if I fix this point up, these points will create anti-clockwise torque. Yes, no?
Yes, sir.
Now one very important question. If I hold the object on this part like this, using my one single finger, if I hold it over here, it will fall in the clockwise direction, right? Yes?
Yes.
But if I want to make this object stand like this without falling, what will I need to do?
You will need to hold it exactly in the
center.
center of the mass.
Very good, very good. I'll have to hold this with the force which is creating the equal momentum, the equal moment as that of these forces.
On the side.
Yes, no?
Yes, sir.
Yes.
Why? Because my this hand, understand this, my this hand is creating the anti-clockwise movement. These parts are becoming clockwise moments. I will have to provide the force which can balance the clockwise moment. If that can happen, I can hold this up. If I am unable to, understand this, if I am unable to hold this object with the force which is equal to these moments ka force, then this object will fall down.
Yes, sir.
Pakka? Yes? Yes, no? It means what? It
Yes.
means what? That if I want to hold this object in the state it is, then I will have to apply equal amount of clockwise and anti-clockwise forces. Maybe by default, maybe artificial. Yes, no?
Yes.
Yes, sir.
Yes? Pakka? Yes, ki no?
Yes, sir.
Now, let's again get back to this point. Let's again get back to this point. If I hold it here, it will fall down in the clockwise direction. If I hold it here, again it will fall down in the anti-clockwise direction. You know? If I hold the object like this, it will fall in this way. Yes?
Yeah.
That is anti-clockwise. If I hold it here, anti-clockwise. If I hold it here, again anti-clockwise. Right? Yes?
Yes.
It is what? If I hold it anywhere over these points, the body will fall down. Why? Because there is an unbalanced existence of moment of forces. Yes or no?
Yes, sir.
In both the directions, it is unbalanced. The amount of clockwise force and the amount of anti-clockwise force is not equal. Why is it so? Why is it so? Because mass on this side, if I hold it here, mass on this side and mass on this side. See, look at the small mass you have. mass on this side and mass on this side vary hugely. And because mass varies, weight will vary. Because G is constant. mg, weight is mg now?
Yes.
Yes. So because mass varies, weight will vary. Weight is nothing but force. Because force varies, moment of force will vary. Yes, no? Right?
Yes.
Yes.
So in case of any object you take, if you want to hold that object, mind it, what I'm trying to say now. By default, if I talk about this object, there is an art of holding this object. There is an art of holding this object such that the moment gets balanced. Sir, is it possible? Yes. There is an art of holding this object such that moment gets balanced, because of which the system becomes the equilibrium. System becomes the equilibrium. Sir, how? How? We will find out.
Creating an imaginary axis.
It's not the imaginary axis actually. It is an axis which is there in the body itself. Okay. So always there is one point in a body. It can be anywhere. It depends upon the geometry of the body. Okay. Yes, it depends upon the geometry and the thinness and the thickness, uniformness, unevenness, all those things will be considered. Okay, considering everything, there is always one point in every body in the universe where if you take this particular point, all other points, can you see them? Yes, all other points will get their moments balanced. Sir, how? Now look here. Understand this. This is distance. This is distance. This is distance. And this is also the distance. Yes, you know? Yes?
Yes.
So, about moment arm. This is moment arm D1. This is moment arm D2. This is moment arm D3. And this is moment arm D4. Yes? What will be tau 1? W1, yeah, go it like this. D1 into W1, tau 2, D2 into W2. Understand this. Tau 1, with respect to this point. Tau 1 is anti-clockwise, tau 2 is clockwise. Can you see this?
Yes.
Yes, no? Mayank?
Yes, sir.
Sarvesh? Sanya?
Yes, sir.
Anuj?
Yes, sir.
Okay, similarly, look at tau 3. It is again anti-clockwise. What about tau 4?
Clock.
Exactly. And this is what is important. Okay, so what is the beauty of this point? I will say this point has got the weight W. By W, I mean W is the weight of entire body. Okay, so this is the balancing point. Hence, I will say this is the point where entire mass of the body is situated. Why? Because if I hold the body at this point, it will not fall. Getting it? Yes, no?
Yes, sir.
Yes. So this is the point of balance. Anuj,
Yes, sir.
this is the point of balance. Mayank,
Yes, sir.
this is the point of balance. So this point of balance is called as center of mass. It is called as,
Center of mass.
this is called as
Center of
center of,
Center of mass.
exactly. You need to understand this. Sir, it is called as center of mass.
no.
Clear? What is center of mass now? Center of mass is that point on the body. Center of mass is that point on the body. So now the moment of forces of all the points across that point when added become zero. Samjha? So center of mass is that on the body such that moment of force across all the points around that point when added becomes 0.
Okay.
Clear?
Yes.
Yes, so this is what you have. Just note this down. Next lecture we will be starting with center of mass concept. Note this down quickly. And there are some numericals which you need to practice. Practice the numericals and bring some doubts and all those things. You have got the physics WhatsApp group as well. Post
Sure.
the difficulties over there.